Next, let me ask you to recall the z alpha notation, which is the z value with area alpha to the right. So if we want to find z.025, that's the z value with 0.025 to the right. So that means that the left area is 0.975. And so our z.025, this is a normal distribution, we can find with inverse norm. And then we just do the left area of 0.975 and mean standard deviation. So we can compute that on the calculator. So we do second variables, inverse norm number 3, left area right there, 0.975, 0.1 for mean standard deviation, left tail, paste it, 1.9599, so about 1.96. So with that in mind, since our sampling distribution p hat here is approximately normal, that means that 95% of the sample proportions will be within between negative 1.96 and 1.96. So if we mark off 1.96 and negative 1.96, then we've got 2.5% of the area here, 2.5% in the left tail, and then 95% left in the middle. So 95% of the samples, that's the data, is going to be between those z-scores. And then z equals 0 is in the middle, and that corresponds to the mean of the sampling distribution, which is the population proportion. So what this is saying then is that for 95% of sample proportions, if you take the population proportion p here, add 1.96 standard deviations, sigma p hat is our standard deviation, and then subtract 1.96 standard deviations, then 95% of those sample proportions p hat are going to be between those cutoffs. That's what this diagram is saying. Right, this is going to be p plus 1.96 times the standard deviation of that p hat distribution. These are z-scores, these are x values, and then p minus 1.96 standard deviations. Well, if you rearrange this thing algebraically, that is equivalent to p, the population proportion, is between p hat plus 1.96 standard deviations and p hat minus 1.96 standard deviations. So here we've got the population parameter is between the point estimate plus 1.96 standard errors or standard deviation, and that point estimate minus 1.96 standard errors. So again, what does this inequality mean? This means that 95% of these interval estimates are going to contain the population proportion. So 95% of samples are going to give intervals, and these are actually confidence intervals. That contain p, the population parameter. So this form of p hat plus or minus 1.96 standard deviations, that is a confidence interval. It's an interval estimate, and it has a degree of reliability attached to it. The 1.96 corresponds to 95% reliability. So that is our formula for a confidence interval. So a confidence interval in general is point estimate plus or minus 1.96 standard errors. For 95%, it's 1.96. If we change the 95%, then this value changes, which is point estimate plus or minus our margin of error. So the 95% there corresponds to z.025, which is 1.96. So that number can change, as can our p hat and our sigma p hat, depending on what our sample proportion is. But that's the general structure of a confidence interval.